The following is a presentation of NoVA Hackers, brought to you by ComputeCycle.
Hi, Joe Klein, Adventures in Time. This is a add-on additional research I've done for the last 2 years since I gave the ShmooCon talk on hacking time. Flip over this. It actually started because of an investigation. I saw some blog entries. I saw some news items. November 20th, 2012, pretty much said, hey, something was going on with time. Something weird was going on time. I'm a fan of time things, science fictions and such. So I started looking and I found in mailing lists, I found things like a PBX having problems. I found synchronization for Active Directory, for Citigroup. I found Juniper routers on the West Coast were affected. And then I interviewed a bunch of people over at the Data Center Row, and they said weird things were happening, had lots of weird help desk calls. They had no idea what was going on. I asked the question, hey, has anybody else seen this? So I looked around, and it looks like FX was doing something about it. And he saw exactly the same thing. He saw that Naval Observatory time shifted back 12 years. Wow, that could be a problem. He claims it may be cyber war. I don't know. All I can say is a bunch of things got redacted. Wow. Actually, a lot of things got, you little bastard. It's redacting again, damn.
The clock is still rolling, Joe.
Okay. Well, there we go. So, what I started saying is, hey, what systems are impacted? So what my research right now is, I'm going around the flip right here, and I'm attempting to look at all the different protocols that impact everything for Internet of Things, mostly because it's fun to mess with little things. Okay, so which protocols are impacted? Demos. If I shift time for 1 week, your demo software can go bad. Days, your DHCP expires. That's pretty entertaining. Is anybody using Bro or, I'm sorry, Snort doesn't detect this, but yeah, you may want to check this out. Minutes. If your LDAP is actually shifted by minutes, specifically 15 minutes in Kerberos, you'll end up losing all connectivity. Your administrators can't log in. Your databases stop synchronizing. We also have cron tabs, other authentication. Your logging can actually be stuck on a specific second. Bummer for the forensics people. Financial transactions. We actually saw one on Wall Street just recently where financial transaction, about $600 million worth of financial transactions happened exactly 600 milliseconds prior to the striking of time. That was interesting. And then we have lots of logging. So that was based on synchronization within a network. If you're actually synchronizing to absolute time, root certificates for SSL, IPsec, and DNS. In other words, your authentication goes down, not just from your single connection, but your root.
Absolute time?
Absolute time. You are referencing a time standard other than your internal time standard. Things like the atomic clock, or you're leveraging GPS, or leveraging something else to do validation. You're not using your own internal, say, NTP. Stratum 2, Stratum 3, unfortunately, with the assessments I've been doing for the last 15 years, network engineers don't know what the hell that is, and security engineers don't look at it, what the hell. Hey, I only have, a few more minutes. I got to speak quickly. Yeah, most are poorly implemented. But yeah. Milliseconds. Basically, GPS, mobile, transportation, electrical grid. We'll talk about the electrical grid in the back. Okay, quick summary of time systems. Basically, we have a clock, which is any node participating in the protocol. We have Grand Master, which basically deals with clocks and other clocks. We have intermediary clocks, which is what we're talking about, Stratum 1s. There's a couple different protocols there. We have masters. And then we have slaves. Slaves are the machines on your desktop and systems that probably should have more accurate or precise time. Okay, Another problem we have here within the time systems, based on your operating systems, they may give you one of these particular results. Therefore, if you don't have a standard for one of these particular results, guess what? Your forensics logs are off. I'm sorry, how many SIMS assessments have I done to find out that half the systems are one or all of these? Therefore, you can never do a forensics analysis on this stuff? Crazy.
How many, Joe?
Probably 4 or 5 dozen, both commercial and federal. Okay, so threat models. This is a current threat model. We have internal and external attacks, man-in-the-middle, and package injection. Here's the type of attacks that I've been able to perform at this point. Packet manipulation, spoofing replays, rogue master, that's really fun. Participation in removal of time and changing L2 and L3 attacks that I've been able to then do attacks above. That's, you have to get it in the middle. Cryptographic performance, if the cryptographic handshake is incorrect, denial of service, and then grandfather spoofing, GPM spoofing. There's also, based on contributions to IETF, there's some work that I've been contributing to for Tick and Talk. Okay, types of attacks right now that I've seen that make intrusion detection and SIMs crazy. And also operating systems. So if we move forward in time for a short distance of time or back in time, if we cycle over long times, as an example, for every hour that I have, I actually reset back to the last hour every hour. Messes up things wonderfully from a logging standpoint. Short cycle, where I'm doing it short enough within a millisecond range where things like the TCAM will actually stop caching, so your switches get sick. We have limits in time in memory, which when you're doing calculations within the cache or of the CPU, limitations in applications, limitations of operating systems. Everybody knows that Microsoft and every other operating system has a beginning and an end from a time protocol. Well, yeah, you can take advantage of those. Operating system limits, beyond those limits and then beyond the hardware. Hardware will typically have a totally different standard. Very entertaining. So, if I'm going to actually create a master grandmaster source, here are the type of systems that I can come from. I typically would want to come from the atomic clock, by the way. If you choose, you can have your own atomic clock. It only costs $2,000. Please do not remove the metal surfacing around it. It causes radiation bad, okay? So, we have wireless. We basically have a 60 kilohertz signal going from this. By the way, if you're in Europe, we have a 50 megahertz that actually takes care of it. Most countries have their own particular standards in the kilohertz from a synchronization standpoint. We have NIST, who does 2.4, 2.5, 5, 10, 15, 20 megahertz range, which, by the way, is both data and voice. You'll hear the voice, but on a side channel, you can actually pick up the data to do both accuracy of your timing standards. We have GPS. We have CDMA. CDMA does not require you to buy a connection to the cell phone carrier. This is an open signal for synchronization. Big problem. We also have wired. We have the public internet using NTP, different sources out there that are available. I would recommend, if you're using anything at all, you'd at least use pull, not a specific one, at least that changes on a regular basis. We still have a modem dial-up that NIST supports. We have a voice dial-up if you really want to hear that again and again, kind of boring. And also, people are using power line synchronization. Oh, yes, is fun. So, frequencies right now, I have frequencies uncertainty up here. Please notice that nothing to the right says there is authentication. So Evil Twin and Man in the Middle for all these wireless frequencies are available. Where if anybody wants to work with me, I'm looking for somebody else to help me with some software-defined radios to demonstrate this. Right now I even have targets I've been buying to make things fun. Okay, examples. Okay, just for the low frequency, this is the project I'm on currently. If I didn't mention this, I gave this at the cybercrime presentation last week. Jim Christie, the old DC3 crew, basically showed up. The only people that were interested, all the regular IT people and security people ran from the room. The only people that were interested in this were the 3- and 4-letter agencies where I received a stack of cards. Pretty entertaining. So, low frequency. Here's all the systems that are actually impacted. What I did was I looked at chip manufacturers that created chipsets within each of these particular set of frequencies. I determined that they were actually in clocks, radios, time clocks, you know those punch things? Yeah, they're in there too. That could be fun. They're in transportation electrical grid. We also have them in cabs. You know the meter as it's actually running? Yeah, that actually uses this particular frequency. That would really be bummer in Vegas, wouldn't it? So we have traffic lights. Stay tuned. I'll be demonstrating that hopefully at DEF CON. Control systems, taxis. We also have electrical appliances. Okay, they're in your house. We're used to, VCRs flashing, so get over it. They've actually put little flashy things inside your system. We also have observation instruments. The weather systems that we're using to actually grab data to synchronize, temperature, weather, earthquakes, things like that. Those are actually using those, and also precision time frequency. If somebody's actually using this time to synchronize an instrument of some sort to then measure other places, you can kind of turn their stuff out of whack. Kind of a drag. Okay, wired protocols. And by the way, I'm at 8:41. Thank you, Rob. So, what we have is we basically have also lots of unauthenticated protocols. Please note, NIST, time of day, the modem dial-up, and also the ATI. This one right here actually is the first one that has any type of authentication. Okay, so we have, if you go around the RFCs and you go read all the standards, these are all the standards of protocols we have that are actually tracking across the internet. You probably don't know. ICMP has been used as a timing standard. It's been out there since 1981. It's still used. There's still tags for it. And oh, by the way, it's very useful. Daytime, I basically did a quick scan of the internet. Port 13, there's 87,000 of those devices currently existing and transmitting. Time protocol, 75,000 of those devices. NTP 3, 4, and 5, 217K of those. I haven't looked for the IPv6 yet. I have to do a reverse of the DNS and go through that process. Stay tuned, I'll have that. We also have a IEEE standard called PTP. It is basically meant as a way of providing very precise time. It's currently used between cell towers. It takes a GPS signal down. It then synchronizes its cell towers to make sure that the radio frequency is in sync, so all phones on that particular system can actually communicate without losing data or without losing voice. We also have NTP4, which is for IPv6. It has a new feature called multicast time, which is kind of cool. Instead of pulling time to all systems, you can have an authenticated system that actually push time. Examples. I already gave you a list of those for the last big NTP flood, only 15K. I have a list of 217K for NTP. This could be bad. Okay, talked about spoofing my phone. This ended very badly because the way Android works is it pulls a NTP signal. It uses that to prim the actual GPS. Well, when you turn your system off, it actually writes that at that particular time. When you actually pull down the NTP and it's the time, say 12 years ago, go away. When it's 12 years ago, basically Google Maps does not work. It will not synchronize. I'm still dealing with that. Very problematic. By the way I perform this, I turn the cell phone off and I use Wi-Fi. I did a man in the middle and basically had fun at that. Okay, wireless slave protocols. Honestly, these are really screwed. These particular protocols, as an example, time protocol. Take a look at what epoch is for time protocol, January 1, 1900. Okay, look at the operating systems those are used on. Also take a look at daytime. We have Microsoft and similar. SMTP is actually a stripped down version of NTP. It doesn't actually check for more than one source. Therefore, single source spoofing is extremely easy in these particular protocols. One note, Windows only guarantees a 2-second accuracy. Anybody do forensics and enjoy a 2-second accuracy within your products while you're looking? Thank you. So I also want to mention BusyBox. How many systems do you know are running BusyBox? Do you have home routers? Do you have Internet of Things? They're all running BusyBox. Life is good. There's a lot of SCADA devices that have web interfaces. They're running BusyBox. So if you actually shift the time back, you can actually go back to 1900 and do bad things. NTP4 does go back to 1900. It does have a authenticated mode. I'm not going to talk about that right now because I only have 4 minutes. So, operating systems. I actually want to mention that resolution in operating systems also becomes important. Take a look at this. If I'm using an Android, from a logging standpoint, I have 1 millisecond, but I'm using MS-DOS, it's 10 milliseconds. And again, we have variations of milliseconds, and we have variations of epochs. Take a look at Microsoft DOS, which goes back to 1980. You shift the time back, things go bad. It's pretty fun. Application languages have limitations. This is a level of what resolution you're able to get out of your application, whatever you're running. Also, take a look at the epoch. My favorite is the, let's see, the 1753 for SQL. That makes me laugh. And then, let's see, oh, missed the slide. Oh well. Yeah. The other one is, where is it? Oh, there we go. 1958, there's one that's back. Oh, 1600s for Microsoft. I know it's not an old operating system, but a little bit too old. Okay, so what are evil things you can consider? What is the accuracy of the electrical grid? Enough said. Okay, end of the story. Basically, Tick and Tock, the claim was that they rebooted the systems. They had multiple systems that were referencing them off of Tick and Tock. By the way, when you actually do a query for books, for Microsoft books and for Cisco books that go back all the way to the 80s, what are the clock sources they recommend you to use? Tick and Tock. Duh! Okay, so basically they had an outage which lasted almost an hour, created 12 hours back. Basically each system's rebooted. So in other words, the protocol is set up where if it shifts more than 100 seconds, it's supposed to reboot. Unfortunately, people have it configured by default with a -G option. What is that -G option? It gets the current time and uses that as a standard. So whatever the time sent to them became the standard for that machine. Life was fun. A lot of systems out there are still in that scenario. Recommendation, go audit this. Don't trust the systems. Be careful, inject your DHCP, hopefully a trusted DHCP. Audit your standards, make sure you have detection systems to detect it. Adventures in Time with 1 minute to go. Thank you.
This has been a presentation of NoVA Hackers, brought to you by ComputeCycle, a Cranial Thunder production.